Good afternoon, everyone. I am Dr. Samir. Today, I am going to tell about the hemodialysis machine, its functioning, the principle mostly, its parts. So, the hemodialysis machine, this is a Fresenius Kabi 5008 machine, which is basically a sled machine. Okay, so sustained low efficacy dialysis. So, basic components, whether be it a sled machine or a normal dialysis machine, is same. So, I would like to tell you about the components. So one part of the machine is the arterial line, that brings blood from the patient to the machine or till the dialyzer, and then a venous line that takes the blood from the dialyzer to the patient. Now the arterial line, the blood has to come from the patient to the dialyzer. That requires some force. As we know, the dialysis line is present in the venous system or in the femoral vein or the inferior vena cava. So that is what to generate pressure we need the use of a pump. So now the arterial line or the inflow line to the dialysate has two parts, a pre-pump part and a post-pump part. So here we see the arterial line, this part, blood comes from the patient to the pump. This is your pump. So from here, the red mark till now that I have drawn is your pre-pump part. Then from the pump is the post pump part, okay, till it goes to the dialysate dialysate machine. Okay, so pre pump and post pump. So what happens is the blood comes from the patient to the pump and then from the pump to the dialyzer. So there are this machine particularly is not having, but generally a machine has some parts in the pre pump part, that is a pressure gauge. Okay, at some part, maybe somewhere here we have a pressure gauge. So the pressure gauge is needed to measure the pressure of the circuit. Now when it is useful, when there is a circuit leak or break, so there is a loss of pressure. This can be detected here and we can get an alarm on the screen. So that is why we generally have a pressure monitor over here. Okay, now once after the pump, again we also have one pressure monitor sometimes, okay, to monitor the pressure. If there is a leak again or a break, then we can know it from the pressure gauge. Also this one, as we see this part here where is the heparin pump is loaded. Now heparin is infused into this circuit through this infusion through this pipe, and sometimes it is in the pre pump, or sorry, this is what here it is given in the pre pump. It can also be given into the post pump. So this is a 4008 machine. We can see this one again similarly coming from the patient pre-pump. This is the pre-pump going into the pump and coming out. Here we can see one air trap. Okay, so that machine did not have, but this machine has a air sensor and a air trap. Any air particles, air molecules that can be present in the circuit because of a break or because of inadvertent inflow into the circuit, that air can be trapped here and is released into the atmosphere. Now this is again the heparin pump. As we can see, this is again infused into the post pump circuit. In the previously we had seen that the heparin was infused into the pre pump circuit. Here we are seeing that the heparin is being infused into the post pump circuit. That varies from machine to machine. So then this is your then again the post pump, then it goes into the dialyzer. Okay, so this is up to the dialyzer. So generally we have a inflow circuit to the dialyzer, that is called the arterial line. It has a pump, and we have a pre-pump circuit and a post-pump circuit. In pre-pump circuit we have a pressure gauge, and in post-pump circuit we have a again a pressure gauge and an air trap. Here sometimes we also have a sampling port from where a sample can be drawn. Generally it is seen in the pre-pump circuit. Here this one, this is your sampling port. Okay, here we can take a sample. So now coming to this, again this part, after dialysis from the dialyzer, the blood goes into the patient. Okay, so from here the dialyzer, the blood, here again there is a sampling port, and this here again this is another air trap, air detector, and then it goes into the patient. This is called the venous circuit or the outflow circuit, outflow from the dialyzer. Okay, so this post dialyzer circuit also has a pressure gauge that can detect your pressure, any circuit, any leak or any breakage. Okay, that can be detected and the pressure gauge will give alarm over here. So I will show again where the alarm will be shown. Okay, so these are the circuit of the blood. Okay, the blood part, the and then there is another circuit which is the dialysate circuit. The dialysate circuit, what happens is, here we have a mixture of solution, here we have a bicarb, and this is your acid. Okay, so solution from here is taken from these two pipes and it is intermixed in the machine. Here behind we see we have a RO water line. Okay, so this is our RO water line. So RO water comes from your supply, and this acid and bicarb, that is prepared solution by the technician generally, they three get admixed and a proper concentration of dialysate flow is prepared and is sent to the dialyzer through this pipe from the back side of the machine. Okay, bicarb solution and acid solution, they go into the machine, they get admixed with the water from the RO circuit. Okay, which is back side, and thereafter getting mixing and preparing a dialysate solution that is infused across the, okay, your sorry, this one. Okay, this is the, that is given into the dialyzer. So here the exchange takes place and the ultrafiltrate or the waste fluid that is collected is sent from this into the drain. Okay, so this is what your dialysate circuit is. The dialysate circuit, how to know the concentration? There is again few components of dialysate circuit. There is one sensor there that conducts the conductivity of the sample. Now since this dialysate fluid is a mixture of acid and base, and along with RO water there is a electrical charge to the fluid. So there is a monitor inside which senses the conductivity of the fluid because it contains electrolytes, and from that it can know the concentration of the various electrolytes, and if there is any difference, any wrong mixing of fluids, it can detect and there will be an alarm that shows the conductivity of the fluid, from the conductivity of the fluid. Okay, so these are the parts of the dialysis machine. One is your blood circuit, one is your dialysate circuit. So we are clear about that. Now we'll go to the next picture. Now coming to the panel. Okay, so these are the display panel. So here we can see there is a UF volume, UF time left, how much time of UF is left, ultrafiltrate rate, our ultrafiltrate goal. Now effective blood flow is the per minute, and the cumulative blood volume till now. Okay, then here is the air detector, which I told if any air is present, there will be air detector, will detect this air, and the air trap, we have to just open it into the atmosphere, then the air will be moved out. Okay, so this is your air detector and air trap. Once you open it, air will be escape, air can escape from the that trap. Okay, and one more thing I forgot to say here, in the dialyzer circuit there is a blood leak alarm. Okay, if there is any leakage of blood into the RO supply, then it can detect blood in the circuit and there will be an alarm that there is a break in the dialyzer that has led into leak of blood into the RO circuit or the dialyzer circuit. That we can see over here. Here is the blood leak alarm. Okay, so then as I said, in the arterial line we did not have a transducer pressure monitor here, pressure gauge, so that can detect the arterial pressure, and if you set a limit beyond that there will be an alarm. But we have a venous pressure, again there is a pressure gauge in the venous circuit or the outflow circuit from the dialyzer to the patient. So there also, if there is any pressure differences or any high pressure, that can detect clots. Okay, so if there are clots, Okay, so there will be venous in the circuit that can be detected. Pressure will increase. We have set a limit. There will be an alarm. TMP is called the transmembrane pressure. This is the pressure in the dialyzer. So there also, if any clot is there or any leak is there or any problem is there, that pressure can also be detected here, and we can know there is a problem in the dialyzer. So this is the transmembrane pressure. Okay. Now this is your, as I said, the conductivity of the dialysate flow. From here we can know whether the fluid admixture of the dialysate is correct or not. Okay. So if there is any problem in the conductivity of the fluid, this can detect and we'll get an alarm. That means there is a problem in the constituent fluid. So we'll get an alarm here, then you can see where the problem lies. So this is the dialysate. Okay. So flow here on and off, we can see this flow gives us the speed of the, as we saw here, 220 ml per minute is the effective blood flow during the dialysis. That is the speed in which the blood is removed from the patient's body and given to the dialysate via the pump. Then this is your heparin. Okay, I'll see in the next slide. Then this here is your ultrafiltrate, where you can control the on and off. We can switch off or switch on the ultrafiltrate, and going into the menu we can go to the ultrafiltrate settings. Okay, so again these are the numerical keypad to enter values. Okay, this is confirm. To when you enter value, you can press this, you will get a confirm. This is your escape. After putting a value of confirming, you escape to come to the main screen. So as I said, this is the rate of the blood flow. Okay, so in SLADE we have very lower blood flow, as low as 180 to 100 ml per minute. This is intermittent hemodialysis machine. So here we have higher blood flow of 290 milliliter per minute. That can be increased or decreased using these buttons. Now this, as I told, this is the heparin. So heparin, there is a bolus dose after some time that it is preset, and accordingly heparin boluses will be given. That is generally added in this machine. We saw it was added post pump pre dialyzer. Okay, in the art line or the inflow circuit, post pump inflow circuit, heparin was infused. Okay, at the beginning a bolus dose is given during the priming of the circuit, and then during dialysis intermittent doses are given. So this is our dialysis uh, screen that shows the setting of the dialysate fluid. So here we can see the conductivity, from where we can know the concentration of the dialysate fluid and the dilution and whatever. Here we see the concentration of sodium, prescribed sodium. Bicarbonate is 0. So in severe metabolic acidosis patient, the bicarbonate concentration can be changed a maximum of to +8. So that helps in severe metabolic acidosis. Okay, then the temperature of the dialysate fluid has to be maintained towards the body temperature. It has to keep between 35 to 38 degrees Celsius. Okay, so that is again a sensor that is present that records the temperature of the dialysate flow, and this is the flow of the dialysate. Again, this can be changed as per our requirement. Now coming this to the ultrafiltrate menu again. So as I had seen in the previous machine, here this is the ultrafiltrate settings. So once you press that button, you will be coming to the this menu. So here we can set the UF goal, ultrafiltrate goal, how much we need, UF time left, that is been set in the beginning. So once you start in, this is the only change thing we can edit. So by using these buttons, or you can directly input the value also, numerical values from the numerical keypad. So once you start entering the values, so suppose I make it now 2000, so another 3 hours is left, so this rate will come down to 600 automatically. Okay, so 630 or whatever. So you can change the ultrafiltrate goal also as your as per your requirements. And already the amount of volume that has been removed shows up here, 847 ml has already been removed as ultrafiltrate. So in the end, I will just show you a schematic diagram of about how everything is in the machine. So this is the patient. From the patient, the arterial line. Okay, so this is your pre-pump inflow. So here we can have a pressure gauge, a sampling port. We can have the priming, or also the heparin. Then here we have the pump. Then this is your post pump inflow. Here we can again have a pressure gauge. Then it comes to the dialysate. Okay. Then from the dialysate it goes to the patient. Here again we can have a pressure gauge, a air trap, air detector, this was the air trap. So this can detect clots, leak. Okay, then to the patient again. Okay, now the dialysate flow, here we have a acid, base, RO water, these three mix together and they are infused into the dialysate. Here we have a temperature probe to keep between 35 to 38 degrees Celsius. Okay, and we have a conductivity sensor to know the concentration of the dialysate fluid. Okay, then from that the blood flow and dialysate, they go in the opposite direction, and the ultrafiltrate goes into the drain. This is your ultrafiltrate. So this is a basically schematic diagram, just a basic idea of how the dialysis machine works. Thank you.